Hi everyone. Welcome to wait, what's happening now? We have wow. So there is a artificial intelligence person here. Ooh. Hey, that's a CGI. I mean, sorry, it's Alex CG. Go on, Alex. Hi, how are you?
Good. Alex CGI, actually. Computer generated imagery at your service.
Hello,
So,
sir.
yes, I am here. I am invading Praveen's channel. I'm taking it over, baby. It's mine now. I'm going to spam you all with HelloFresh ads.
So what's happening today? What are we doing? How are you going to take over my channel, by the way?
So I'm going to subject everyone to only the very dankest of memes. We are going to use Jina, an open source search framework, to build a meme search engine from scratch.
Interesting. Always the workshops are super cool. So go on. Tell us what you have got.
Right. Well, first of all you need is your computer. We can do this all in the web browser.
Yeah.
I'll give a quick presentation first, and then we'll jump into the Python notebook and we'll get coding.
I am zero in Python. Is that okay? Will I be able to understand anything? I'm a
well, I'm sure I can put a chip in your head that'll help.
That works. Sure. Let's go on.
Alrighty then. So I'll share my screen and we'll get this party started. Okay. We can start with an example of what we're going to build.
Okay.
So this is the live example. You can go to examples.jina.ai /memes
Okay.
and just search for something like, I don't know, memes about chocolate. Dum-de-dum. And yes, here we go. We've got the Kermit, we've got the Drake, we've got the Galaxy Brain, Winnie the Pooh, and so on. We could do Squidward memes about school. Boom. Yeah, I don't know why that's a dead link.
Oh, so, yeah. That happens. Never trust missions, right?
Well, you can't trust me, and I am one. So yeah, this is just a simple example of what we'll be building. In the example online as well, you can search by image. So grab files. Where is a meme? First, for example, Doge. And we would find similar Doge memes. So this is matching image, and this one is matching text. Today we're just going to focus on the text one.
Sure.
So yes, without further ado, I'll give the presentation. So yeah, welcome to the Jina workshop with our cute little icons. So the problem we want to solve today is, how do we build a search engine for memes? As you know, that's why you're here. So if I feed in the search term poo food, and I mean Winnie the Pooh, not the other kind, because that'd be gross. We get things back like this: finger food, hors d'oeuvres, cereal, breakfast soup, eating Cheetos, eating cheese puffs. So you'll notice that only one of these has the word food in it.
Yes.
That's because we don't just want to search keywords. We want to search semantics. We want to search meaning. So we're using an AI to do this. The AI knows that cereal is food. It knows that soup and breakfast are food. I mean, Cheetos are barely food, but some people call them food in America, I believe. Another example might just be searching one word like chocolate, and then we'll get a whole bunch of different memes. Yep, as I said, the example is on examples.jina.ai. We've got a big data set of memes. We indexed, I think, 30,000. Soon it'll be 200,000.
Wow.
Yeah, I have way too much time on my hands. So yeah, in the workshop, I'm going to give a quick intro to neural search. That's AI-powered search, in other words. Talk about Jina AI. I'm the developer relations dude at Jina AI, and yeah, we build the framework to build the search engine. We'll do the workshop to build the search engine itself, and then talk about some next steps. So first of all, if we're talking about search, what the heck do I mean by search? Normally when we think of search, we think of going to a text box, typing some stuff and hitting enter. So like LinkedIn, Amazon, Stack Overflow, Google.
Very curious. Why is Google not listed in this? Because that is the mother of all searches, right?
Well, because it goes without saying, doesn't it? Everyone already knows Google. But yeah, search can be so much more. We can do things like similarity search. So if we have a bunch of PDFs, let's say papers about machine learning, we can upload a paper and then find similar papers in that data set. Or video to video matching. Audio to audio, if you want to find the latest Beyonce songs, and who wouldn't? Even App Store is a search. Image to image. This is really common in e-commerce. And even a chatbot is search. But instead of bringing you back the top 10 or 100 results, it just brings back the top 1 result. So search is everywhere. If you use Tinder, you're basically using a search engine. You're searching the right person for you, and it's got an algorithm behind that. So that covers search. But what's neural search? So in neural search, we're using an AI to take a whole bunch of different data and work out how it's connected to each other. So for example, if we have a data set of Pokemon, we've got 2 images here of Bulbasaur. We've got one of Charmander. And obviously as a human, we would put these 2 together because they're green, they're sort of planty. So we'd put them on one axis of a graph. And yeah, poor old Charmander here would be lonely, all alone on his side. And we could do the same with Pikachu, with Raichu, with all the other Pokemon I don't know the name of. I'm going to redo this slide soon and do it with Marvel superheroes because that's always more fun.
Pokemon will work better because a lot of folks here, we have like Harini, Mukul and Loveline. I believe everyone in India and the folks here, they all love Pokemon. This actually works.
Nice.
Works better.
So yeah, when we feed these images of Pokemon into a neural network, the neural network looks at them and makes connections. Now that neural network could be the one in your head, your meat-based neural network, because that's what it is. It's a network of neurons, right? Firing and making connections. We see the 2 pictures of Bulbasaur. We know they're the same because our neurons are firing together. And with a deep learning model, with AI, it's exactly the same. Just instead of being made out of meat, these neurons are made out of silicon. So the advantages of this is it's semantic. You know, we look at these and we're not just looking at the pixels. We understand that Bulbasaur is a plant-based Pokemon. We can't just tell that from pixels, but we know that meaning. It's data type agnostic. So you could easily just change this for words. Let's say you have dog on this side and cat on this side. And then you have the word kitten. Well, the word kitten would be this side. You have the word Dalmatian, that'd be this side. Or you could do it with anything at all. Video, amino acids, we've got a project going on in that regard, 3D meshes, whatever. And there are a whole different bunch of models. And by models, I mean the different neural networks. So the neural net is the brains of the AI-powered search. So if you want to switch, well, let's say you want to learn French really quickly. A good way might be to pull out your brain and put in a French brain. Yeah, that doesn't really work too well for humans, but it does work with Jina's framework. You pull out the English language model, you put in the French language model, and that just means changing one line of code. Simple as. Typically, in the past, neural search has been difficult to deploy as more than a toy, because all of these deep learning models and libraries, they have complex dependencies. So let's say package A relies on PyTorch 1.2, and package B relies on PyTorch 1.3. And you can only install one version of PyTorch at a time. They won't work together. That's what Jina is solving. We are all about infrastructure and optimization. So we make it easy to build and deploy these things. And me, I have no background in machine learning. I don't even have a background in computer science. I studied Chinese, for God's sake. But here I am. I can build a meme search engine. And I built that meme search engine from scratch. So yeah, our mission is to provide an open source neural search ecosystem, allowing anyone to search for any kind of info with high availability and scalability. We can search all kinds of things. We've got examples of all of these working. Text, images, or yeah, you can see it. I don't need to read it out for you. You can read. So in Jina, we have three main concepts you need to understand. And that's it. Simple as pie. Well, pi is 3.14, but three concepts. So first up is a document. And a document can be any piece of data. So in our meme data set, one meme is one document. If you want to build a search engine for Marvel superheroes, each superhero profile would be one document. Things like that. And document doesn't just have to be text. It can be anything at all that a neural net can understand, like frames of video or, yeah, you name it, amino acid strings. We have an executor, and that's how Jina processes documents. Let's say your document is Romeo and Juliet. That's a really long document. It's going to be a pain to work with because maybe you want to build a search engine just for a certain sentence. So in that case, you would segment it. You would cut it into sentences. And there'd be one executor to cut it into sentences. You would encode it. That's putting it on the graph that I showed you with the Pokemon. And that's the job of another executor. And then you would want to index it. Because just like a book, when you want to look something up quick, you go to the index. So yeah, three executors in this example, and they are all connected together in the flow. It streamlines and distributes executors. So you can run executors locally, on Docker, in the cloud, just in a few lines of code.
So there is since you said Docker, there seems to be a question from Madhu Padawala. Will using Docker help the dependency issue?
Oh, yes. Yes, so much. Because everything's running in its own little sandbox. So this version of PyTorch is isolated from this version of PyTorch. So they can coexist happily. And we won't be using Docker in today's workshop. In the live example I showed you, that's using Docker for a lot of stuff. But since we're doing it in a notebook that runs in your web browser, Docker really doesn't play well with that, unfortunately. But in the real world, I would highly recommend going with Docker. I always think of it, I am a huge Linux geek. I've been using Linux for decades now. So I think of all of this stuff like bash, like using a shell command. So in the shell, I would take my document, I'd pass that to a cutter, and pass that to an encoder, and then pass that to an indexer. So the document would go through each of these steps and then be spat out. And we have it just very similar with Jina. We make the flow, we add these different steps, and then we push the documents through the flow. Oh, but bash plus apt-get. So apt-get installs packages for you, right? You don't want to write every piece of software yourself. Ain't nobody got time for that. So with this, you can just put GinaHub / and cool new encoder or whatever module you want. We've got a whole bunch of pre-built modules, pre-built executors, I should say. You can run them in Docker. You can run them without Docker, just one line of code. When we introduced this feature, my programs went down from, 500 to 1,000 lines to 80 lines, just because all of this stuff is pre-built, fire and forget. So yeah, Jina is the main framework, and Hub is like the app store, like the apt-get. So in the workshop today, as I said, we're going to build a neural search engine for memes and go over some of the basics, but in practice. And let's jump in. So first of all, you'll want to open your notebook. This is a pre-built notebook. Actually, I'll put a link in the chat. Where are we?
Alex, would you like to? Okay, on that chat. All right, go ahead and put it over, and I'll try to. Yeah. Okay, I'll try to put it on the live stream as well. Yeah, go on.
Okay, cool. So yeah, this is a Jupyter notebook. Well, Python notebook running on Google Colab. So if you follow the link, this will open in your browser, and that's all you need. Notebooks are really fantastic for building proofs of concept, for testing things, for workshops, for sharing. I wouldn't use this for any real world activity. I would, do it on my own system and push to the cloud. But for now, this is really useful. So first of all, we'll do some basic setup. Now, as I said before, I indexed 30,000 memes for the live version. But man, it's going to be a long workshop if we do that. So let's just say 50. We won't get amazing results because it's only 50 memes. There might not be any memes about food or chocolate, but it gives us something to work with. Run it anyway, because why wouldn't you trust this wonderful face? It takes a little while to connect. Actually, just let me check something. Tools, settings, miscellaneous, kitty mode. Always turn on kitty mode. You'll see why. We'll install some prerequisites. So basically, we need to install the Jina library. If you do a bang before the command in the notebook, it'll execute it as a shell command. So we're going to use wget to get the requirements, because we can't store stuff in Google Colab, at least not long term. And then we'll install the requirements. And this is why it's called kitty mode. It always takes a while to install requirements. Jina itself is pretty lean. We have very few prerequisites. Little green tick means it's all done. Now we'll download the data set. So one way to get a data set would be to manually save every meme and type in all the caption information or OCR it, and it's just, too much work. So we're going to use a data set from Kaggle. Kaggle has a whole bunch of open source and public domain data sets for us to use, totally free of charge.
And I'm completely new about this whole thing, this Google Colab and other things. But I mean, like, what is that cat doing there? Like, that's so cute. And I'm actually a cat lover. And how does that work? What exactly is this thing? Like,
it's an Easter egg in Google Colab. I did not code that. That's nothing to do with me.
Okay.
We can also turn on corgi mode, which I haven't tried. So
oh my God.
Dogs as well, I suppose.
Okay, this is completely.
Yeah, there we go. There's a little pupper.
Oh, they don't meet each other. Okay, I'm out of the stream then.
So yeah, as I said, it's a public domain data set. There are about 200,000 memes in there, and it includes a lot of rich metadata, which is why I chose it. Well, one of the reasons I chose it. So it has the images, it has a JSON file, and in the JSON file, that contains all the captions, all the template names, and so on. And I'll go over those a little bit later. And you know that if you deploy a meme search engine in the real world, some people are going to search for horrible, horrible words and try to find racist memes or sexist memes or whatever. So I searched through it with all the mean, nasty words, didn't find anything too bad. Memes always like to be a little edgy, but these are relatively clean. It does kind of suck, like any data set, especially for memes, because memes are always coming out all the time, changing all the time. So this data set is from like a year ago, so it won't have the latest memes. But that's just a fact of life. There was no other really good data set out there. So we'll create a directory and we'll get the memes. We're hosting the memes on a Jina server just because it's a public domain data set. And if we try to do it from Kaggle, we need to create an account, and that's a lot of work for everyone. Yep, got it. So let's just check it here. Data memes.json. I am going to turn off the animals. It's a little distracting for me.
All right, sure.
Oh, I feel lonely now. Okay, so now we've got the data. We need to load the data into our notebook. So as I mentioned with Jina, we have documents. A document, in this case, is one meme. We are going to take all of those and put them into a document array. And if you know what a list is in Python or an array in JavaScript, it's just like that. It's just putting the memes into one box, one list. We might shuffle the memes, and you'll see why in a bit. We'll create a document for each meme because Jina doesn't understand memes out of the box. Everything we feed into Jina has to be in the form of a document, but that's relatively straightforward. We're going to set the document text to the template name, in this case, surprised koala, plus the meme caption. This is poisonous. What? And we will populate some tags. For example, the URL to this image, so we can see the image in our browser. So do I need to run any code here? No, okay, we're good. We will import the two things, document and document array. And when you work with any data set, you need to always write some kind of function to process it, unless it's a super, super simple data set, like a plain old CSV file or a text file. In this case, because it's JSON, it's quite structured, so we need to unpack it a little bit to pull out the juicy memes. Every data set, you will write a different processing function, so don't get too hung up on this bit. Let's run that. This is just creating a function. We're not actually running the function. Prep doc, so it takes an input file. It takes the number of documents we want to work with, as I said, 50. And it says we can choose to shuffle or not. By default, it shuffles. But let's have a look what happens if we don't shuffle. All right? Okay, we've run that. And let's take a look at the top 5. Show images. So, yeah, if we don't shuffle, it's all just hotline bling. All Drake hotline bling, because that's the way the JSON file is organized. It's organized alphabetically by template name. And yeah, this is why we want to shuffle. We want a mixed up data set, so we're more likely to find something interesting. So this time we'll shuffle it with shuffle true. We always shuffle it in a similar way. We have a random seed. So if I shuffle it today or tomorrow or the day after, it'll always be shuffled in exactly the same way. This is just so if I want to change the brains of this, I can compare apples with apples. Otherwise, you're getting completely random results every time and you can't really compare. So let's see the shuffled images. We've got the top 5 shuffled. Okay, see? So that's a lot better. We've got the most interesting man in the world. We've got Hard Luck Harold. We've got Office Space, Dr. Evil, and Yoda. So nice set there. Now let's get a few more. Actually, we just did that, I think, but yeah. So now we've got our documents in the document array. We've got 50 memes in the document list. Now we need to set up our flow. As I said, our flow contains executors, and each executor does one little thing. In our case, we have two executors. We have an encoder, and that looks at the memes. It works out where do they go on the graph. How similar are they to each other? And it builds one big graph with a lot of data points, and these data points are different memes. And we have the indexer. So that creates an index of all of these data points for fast lookup. We're giving them names just so we can keep track of things more easily. If you're running something in Docker, the name is super useful because you can look at your Docker container and it'll include the name of that. We're going to use install requirements true. Oh God, the police are here. They're on to me. Yeah, so the encoder we're using is spaCy text encoder. If you've worked in machine learning, you might have heard of a library called transformers. That's a super popular one. I find spaCy to be a lot faster, like 10 times faster and pretty much as good. And we're pulling it from Jina Hub, like I said. Jina Hub is like the app store for all the different executors. So anything you want to do to process your document or documents, you can do it with packages from Jina Hub. It's weird. Okay, yes. We need to import flow, and then we'll set up our flow. Okay, so that's all done now. We haven't passed the data in yet. We've just set up the pipeline. And now we'll feed the data in. So first of all, if our workspace exists, we want to delete it. And the workspace is where Jina stores our index. So if you think of the encoder like a brain, the indexer and the workspace are the memory. You need somewhere to store your memories. If you don't store them, your brain has nothing to process. So we store the memories, the index, in the workspace folder. So we'll delete it if it already exists, and then we'll take our flow and we'll run flow index. So that passes the data in to the encoder, to the indexer, and it spits an index file into the workspace folder. We'll put the docs as the input, and the request size, good one here is 64. So that means it'll pass the memes in batches of 64 at a time. Because we only have 50 memes, it'll just be one batch. So let's get that going by hitting Shift-Enter. That's what I've been doing instead of pressing play, because I'm a keyboard junkie. Yeah, it's downloaded spaCy text encoder from the hub. It's unpacking it now. And this can take a little while the first time you do it. And because it's in a notebook, it always thinks it's the first time. While we're waiting, are there any questions?
Let me check. Yeah, actually, no, nothing yet. The only question that we had was from Madhur, and that was about the Docker thing. So it's about the dependency thing. And
Okay.
apart from that, there's no other questions. And is the stream steady? Can people who are here make some noise? That would be awesome. Okay. So far, no questions. People are like, I guess they're all listening to what you're saying.
Okay, great. So yes, our indexing flow has finished. And as I said before, it creates a workspace folder, and that stores all the memories. That's what we're going to search through when we actually do the search. So we're talking about a two-step process. First of all, we build a flow to look at all the memes that we've got, or at least the top 50, and then, understand them, store that in memory in the workspace folder. Next up, we're going to run a search flow. So in the search flow, we are giving Jina a new document with some new text. For example, let's say school, or it could be anything, chocolate or banana milkshake, or I must be really hungry. I'm just talking about food. As I said, Jina understands documents, so we need to do this as a document. We'll open up the flow again, the same one, but this time we'll use flow search. So it'll search through the memory this time. We'll, assign this to the response. We'll input the query doc and we'll say return results true. Okay, so it's spinning up again. Yep, and it's done. So now it's found some matches for us. So let's see what those matches are. Okay. We want to get the images of the matches. Okay. So here we are. My uncle's diploma says he graduated from the School of Fine Farts. At least it did once I made an adjustment with a Sharpie. That's definitely about school. I mean, school is right there. First woman president, I don't know why that's there. So, not every model is perfect, just as not every human brain is perfect. So we've got college here. So that's definitely school related, but again, not using the keyword. So this is an interesting one. Walked up to a girl sitting at a 2-chair table and asked if the seat was taken. Blah, 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 blah. This is something that when I read this, I think of this happening in a school. It's the kind of thing that happens in a school cafeteria. It doesn't mention school, but so the model is picking up something. And these models are often black boxes. We don't know why they think what they think, just as we don't know why Donald Trump thinks what he thinks, or any person thinks what they think. When your parents take your phone, well, I mean, it's parents have kids and kids go to school, I guess. But we only indexed 50 memes. So maybe there aren't that many memes about school. So it's trying to be flexible and, find the closest things. And that's the thing about using a neural search. It will always bring you back results. They might not make any sense, but it will always bring back the thing it thinks is closest. So if you type in, well, I guess we can try that now. I don't know, let's say flurble, global, foppity, foo. It doesn't mean anything. So let's search. Oh, okay, little bunny foo-foo. Wow, okay. But like a lot of these are completely disconnected. But like I said, it'll always try. Where were we? So that's basically how you would build a meme search in your browser. If I were doing it for deployment on the cloud or something like that, for example, doing it like this, I'd use a RESTful API. That means users can communicate with it over the web. So in our notebook, when we did flow search, we passed the document directly. If you're doing it in a RESTful way, you would say protocol HTTP, you'd give it a port, and then you'd block it. And blocking it would just keep the flow open. So anyone with access could send a query. I would use Dockerized executors as well. It just keeps the system much cleaner. So instead of using Jina Hub simple indexer, I would go Jina Hub plus Docker simple indexer. And that's basically it. Other things you could do might be to change the model. As I said, we're using Spacey here with the medium size dictionary, I guess, with the medium sized model. So I tried it on the small model. The small model's a lot faster, but it's a smaller brain. It doesn't have as much power. There is a large model, an extra large model, but again, those would take more time to index things. Yeah, so just popping back in to the deck. To recap, Jina provides a design pattern for building a search engine. As I said, the document executor flow. You bring your data, and it says here you bring the model. You can bring your own model and integrate it in there. So if you have your own neural network that's been fine-tuned for, I don't know, searching Marvel superheroes, then yeah, you can plug that in and feed it one Marvel superhero, find similar Marvel superheroes. But you can also just download the models from Jina Hub. And all of these encoders, we have ones for images, ones for text, they're all pre-trained. So just use them out of the box. And I didn't do any training on this at all. Yeah. So back to this. Yeah, with neural search results are only as good as the neural network. Just like if you try to do an exam and you've had a lot to drink the night before, you're not going to do very well. Your neural net won't be in good shape. So you have to use a neural net that's in good shape. And depending on what you want to do, there are different neural nets out there. For text, Transformers and Spacey, I find it good. For images, we have Clip. That's what I'm using for the image search. And there's different models for audio, video, French, English, Hindi, Urdu, all sorts. And this is actually hub.jina.ai. Yeah. So yeah, next steps, if you want to find out more and get started, you can go to get.jina.ai. That will take you to our repo. Bring that up now. So this is our GitHub repo. As I mentioned, we're completely open source. It tells you how to install it. You can go to the docs. We've got a lot of tutorials now about building a simple chatbot or fuzzy grep or things like that. You can run examples on your own machine, our fashion search, our QA chatbot, and so on. And then it goes into how to build your first app. You can also join our Slack at slack.jina.ai. And of course, we're on all the social networks as well. And every month, we hold an online event on the second Tuesday, Engineering All Hands. For Hacktoberfest, we're running a special one centered around how you can contribute to Jina. And usually we share what's going on, we share tips.
And you said something that's going to trigger everyone to come in and contribute to it. Hacktoberfest rocks.
Oh yeah, man. Hacktoberfest rocks indeed. We're putting together a list of good first issues. We're having a lot of talks, a lot of activities around Hacktoberfest. So you're all more than welcome. Join the Slack and you can learn more there. The All Hands is, second Tuesday of every month, 5:30 p.m. to 6. It's not that. It's to about 7 p.m. IST. And you can just Google Jina Meetup to join our meetup group and find that. Yeah, cool. That's all. That's the whole deck. So I'm more than happy to answer questions.
Cool. Awesome. So that was super cool. Any questions so far? Folks are so quiet. We have got a lot of viewers as well. So anyone? So we have Devraj, he's a designer, and there is Monish and Bhuvi. I guess Monish and Bhuvi both are Python developers as well. And we have other folks as well. So there seems to be some issues with people not able to chat. Others, that's what Jyoti was telling me. I'm not sure. I'm just trying to figure it out. So that's the reason I was not in the stream at all. But it was really really exciting, and yeah. So I believe Alex is open for all the questions that you might have. Any questions? Would you like to ask anything or something like that? We had 70 people in the peak. That's awesome.
Not bad.
Yeah.
I guess memes are popular.
Exactly. And then I was also putting a meme in between in LinkedIn and Twitter and sharing the links as well. So that might have actually brought more people to here. So let's wait for another few more seconds and we'll go ahead and close it off. What do you say?
Okay.
In case if there are no questions or something like that.
Yep, sounds good. I'll stop the screen share.
Yes, sure. Cool. So yeah, so we are up for questions, and this is super cool. So so this is just not only. So have you, by any chance, remember? Do you remember this particular reverse image search engine called Tin Eye? Was there
That takes me back? Yeah.
Exactly. So now Google image search is, I don't know whether it is far better, but Tin Eye was like giving you the precise results and other things. So how would you compare Tin Eye, Google image search, and Jina AI? Can one person, like a developer like me, will I be able to create a reverse image search algorithm just using Jina AI?
Easily. Well, okay. I don't want to say easily. That might be over-promising. But in under 100 lines of code, you can certainly build image-to-image search. And Google open sourced the model that they use for their image search. So you can use that in your Jina image search as well. I'm not sure if it's the latest one they're using, but it's called Big Image Transfer. I would recommend using Clip because Clip has feature detection. So Clip would detect the edges of my butterfly glasses. It would realize, oh, somewhere in its computer brain, it would realize, oh, butterfly, instead of just wibbly wobbly edge.
Got it.
Or, yeah, it'll find, if you show it a picture of a kitten, it'll detect the ears and the eyes, and it won't really know what the ears and the eyes are, but if it sees other ears and eyes in kitten shape, it'll match them up. Whereas I think Big Image Transfer is more based on pixels instead of features. Yeah, I ran a quite exhaustive test on my blog. Hang on, I'll open that up. Blog, there it is. And I'll share my screen.
Sure.
So this is just from me noodling around with Jina and different models. If you want to read more, you can go to blog.alexcg.net. And yeah, this is a lot of the stuff I learned during building the meme search. So these are the two common models we use in Jina. Big Transfer is what I started with, and I moved on to Clip.
Got it.
So again, it's just a case of changing a line of code and maybe passing a few other settings. So if you're just going for pure similarity, there's very little difference. You can see the results are slightly different, but they're all Doge. Clip is a lot slower, so there's that. And yeah, sometimes, I mean, this meme, I am Sparta, is in the data set, as you can see. And there are quite a few Sparta memes in the data set, but both of them had trouble with it. I don't know why. And yeah, I dug into it quite a lot more as well. Clip is actually better generally because you can feed it quite a different query image and it'll find what you're looking for. Yeah, for some reason uploading this one, it matched it with Sparta. And this image of SpongeBob, it's a completely different image. You know, the style is very different. The background is different, but it detects the big
There are a
Google
lot of
eyes
features that you can compare and contrast, right? Like it is almost, it's the same. Okay, yeah, it is not exactly the same thing, but
Yeah,
kind of. Yeah.
it's pulling out the features. So sometimes it does really well. Sometimes it does quite badly. I was sure I had a meme with a blue bobble hat, but no. And the red button, I thought we'd be getting this kind of meme, but no, we didn't. I don't know why.
Damn. Okay.
Seagull, I thought seagull meme, surely, but no, cat memes.
What? Wow.
Yeah,
Cool.
and the weirdest thing for me was, like, I upload this image, I expect this image, but I get Dr. Evil. Which,
But both are the same people, right?
different actor completely, but
Oh,
bald guy,
okay.
bald man, so it kind of works. But then I upload Baby Yoda and I expect to get Yoda, and I get Captain Picard. So I search Kermit and I get Yoda. Again, I'm expecting this. Yeah, it's not perfect. It's very good generally.
No, as a human, when I saw if you scroll down, the Picard thing, the Captain Picard ones, if you see this, the first line when you try to give the query image as Captain Picard, I could actually consider these things might be similar, but yes, the expectation is like extremely cool, like it's the same thing, but I don't understand how just by colors it is trying to match. I guess the bald head and the background, the seats are the same color as Yoda, so Baby Yoda, and but to be honest, I cannot compare Baby Yoda and adult Yoda, but the third one was like completely unexpected. That's like extremely unexpected. How can these two things be? Even for a human, it is not similar. Not sure how Jina AI understood these two are similar, but that's a different.
It's, as I said, Jina, we provide the design framework. So the models, the neural networks themselves, are not developed by us. They are open source models, and these things have been developed by huge companies like Google themselves, Spotify, Facebook. So these are state-of-the-art, cutting-edge models that are used extensively in the real world. So,
and plus, they do know that these kind of flaws exist. I mean, is this a flaw? Can this be classified as a flaw, or is it like some wrong implementation, or what do you suggest?
That's a good question. It might just be because we didn't index that many images, so it doesn't have much to work with.
So it all depends on how much indexing that has been done so far.
It's for this we index 30,000, but
okay,
yeah, but it's like if you've seen one dog in your whole life, let's say it's a Dalmatian, and then you see a corgi, you're not going to make the connection that they're both dogs.
Got it.
So if it hasn't seen much Captain Picard before, it's going to have a weak idea of Captain Picard.
But now I coming back to what happens is, like, I could think of how much Google is indexing and to give you even a normal result. So we can clearly see, oh my God, so much indexing is going behind. I mean, yeah.
Oh yeah, the more data you index, the more memories your model has, and the smarter it is. It's like if you have a baby. Babies are kind of dumb. They haven't had time to learn stuff and fill up their heads. Yeah. You need to fill up your heads. You need knowledge and you need intelligence as well.
Okay.
So the knowledge is the data set, the stuff that you index, and the intelligence is the model itself.
Okay, so I'm still confused with this. So you mean to say that, okay, when knowledge is the data set and intelligence is what we develop, like Jina AI is the intelligence, do you say? Or
I would say that Spacey or Transformers are the intelligence, because Spacey is the brain here. Jina is just connecting the brain to everything else, and it lets you swap brains out easily. It lets you swap out the neural networks and deploy them. So as I said, Jina itself isn't inherently smart. We just make it easy for you to use smart things.
Got it. And coming back to people like me, for example, I'm just a web developer, and I'm a peculiar person who doesn't know anything related to Python, and I know only JavaScript. So what is the advice for me that you would like to give? Like, I want to use Gina. I mean, like, the possibilities are limitless with whatever is seen here, and how will I benefit? I want to get benefited.
So I would say you will need some Python under your belt to be able to use it effectively. But a good place to start is by looking at the example code that we have. For example, this is the code for the image search that I showed you, the main image search, not the text search.
So 100% we need to know Python in this case.
Yeah. It's like if you want to build a web front end, you really need to learn JavaScript and HTML and CSS. You can't not know that.
Right.
So this is the code for the image search backend. It's only 75 lines, very short. Because
I mean,
again,
my question is, this simply looks like a normal. I mean, like, I don't know Python, so I might be wrong, but it looks like a couple of functions, function calls, and stuff like that. Can't it be done using Node.js? Node.js also works on the backend, right?
All of the infrastructure this is running on works on Python.
All right.
So the machine learning libraries, I mean, in the world of deep learning and machine learning, almost everything is on Python. So you could easily write a front end to interact with Gina.
Okay.
That's what, like this one. Actually, this one I did write it in Python because my JavaScript is rubbish. Using the Streamlit framework, which I really like. Okay. But yeah, and actually this should be a lot fewer than 75 lines because my code's kind of messy with stuff I've commented out. But it's all very straightforward. You don't have to know any deep learning or machine learning to use Gina.
So this one like kind of abstracts those two things, but you need to know the Python as the language. Otherwise, you're good. Great.
Yeah, exactly. If you want to find the repo for this, you can go to AlexCG1 on GitHub.
Would you like to paste it here? I'll just put it on the YouTube chat as well.
Okay, hang on. I'll just post a link to the repo direct. So this repo has the front end, it has the back end, it has everything's there. Yes, hang on. Chat.
There should be something in the floating bar. Yeah. Cool.
Yeah.
Cool.
There we go. And I'll post the live example as well.
Sure.
Oh, and I'll post my blog while I'm at it because there's a lot of background on meme search on my blog. And a lot of other stuff too, admittedly. But
cool. I'll just pin all these links, which is really cool and very helpful.
Okay.
Excellent. Cool. That was really awesome. So by the way, this is Alex's blog. And this is how it looks. So random brain farts from a butterfly obsessed caffeine fiend.
Yeah, my side project is building animatronic butterfly jewelry. So
oh wow,
robotics.
Got it. That's super cool. Okay, yeah. So yeah, that's really cool. I mean, I don't know if who enjoyed it, but I really enjoyed the whole stream so far. And yeah, so here's Alex CG, a CGI generated artificial intelligent person who is super cool to hang out with and learn a lot. I wish I really had a knowledge about Python so that I could have understood much better. Now I'm really interested to see if I can kind of make a small broker application by having this Python code, and then there is a node code which I know, and I can try to interact the node with Python and make the node have an API that interacts with the front end, which I can write it using React.js. Any React.js haters? Yeah. So, and maybe I can try doing something cool, and that could be a Hacktoberfest challenge as well. So
for sure. And I mean, Gina has a RESTful API, so talking to it with JavaScript should be no problem at all.
Awesome. So then that should be it. Um, I guess I'll try to do something really cool. And yeah, any questions, folks? How many of you are watching? Just put a small hi in the chat. And yeah, if there is any questions, then that would be super cool. So Anushka is already here. Oh my God, Anushka, I believe you are a Python developer as well, right? So um, any questions? Anything? So Jyoti is actually kind of like in the back seat. She's actually driving us. You have to check out the LinkedIn group chat for that, Alex. She's doing like, oh my God, we had fun in the chat as well while you were explaining things, and that's the reason I missed a lot of things. But oh my God, one of the best
Joe is
live streams.
unstoppable.
Exactly. Oh yeah, Anushka is Java developer. Okay, so it's yeah, I'm gonna get this to all the Python developers and gonna ask them for a cool idea. And anyone who would like to get some swags from Jina AI? No.
Well,
Say
Joe
yes right now. Sorry, what?
Jyoti is the person to talk to about that.
Excellent. So yes, so we'll get Jyoti on the stage in some time, not today, obviously, but next time if we are getting more than 100 people to watch this time. So we got around 85 this time, but if there are more than 100 people coming in, maybe Alex, can you say like you're promising to give a lot of t-shirts and goodies and stuff like that?
Well, stay tuned to the blog. We do have a post up there about the swag that we're offering and what you need to do to get your hands on it.
Wow.
India deliveries should start soonish, we hope. It's a little difficult logistically.
I'm in the UK. Give me something.
Oh, okay. Wow. Much easier in your case then.
Okay, then we will say for our subscribers who are in India. So yes, don't worry, folks. You will also get something.
All right.
That was awesome. Thank you so much. Thank you so much for your time, Alex. And this was one of the best streams. And yeah, so as usual, stay safe, stay home, and follow the local COVID protocol. And any last lines to say before we end the stream?
Join us on Slack. We'll probably hold another meme competition in the next few months. Where
exactly
last time we ran a meme contest, people created memes about Jina. They won exclusive swag, personalized 3D printed medals. So really god tier stuff. I'm looking at action figures next time with people's faces on them, but we'll see.
Let's do that then. Awesome. So all the best with your like in case if you're coming with any kind of like awesome creative ideas to submit to Jina AI, don't forget, and I'll update all the links in the description with all the instruction and other things. And I'll also add all the what should I say? I'll add all the links that Alex shared in the description as well. So come back soon, and we are gonna get Alex in the stream again, once again, if you are okay with that.
Looking forward to it.
Awesome. So next time will be another workshop. Will be more interesting as well with another awesome topic. This time it was meme generation, meme search, and next time will be, let's think about something for the hackathons that are going in the weekends as well, if you know what I mean. Cool then.
All right.
See you all, folks.
Bye, everyone. Have a great day.
Bye, folks.